Good morning, my YouTube viewers. It is Crystal here. I'm just here this morning because I wanted to do a code review with you to go over LSTM, BiLSTM, and GRU. And GRU. And the reason why is because I went over ARIMA, LSTM, and GRU, but I wanted to go over BiLSTM. And so basically what we're going to do is we're going to go over the data for COVID-19 because I had to find the time series database. So that's what we're going to do. We're going to be focusing primarily on LSTM and BiLSTM. And because of that, I just called up Google and I said, what's the difference between LSTM and BiLSTM? And it says bidirectional LSTM is a recurrent neural network used primarily on natural language processing, but we're using it on time series. Unlike standard LSTM, the input flows in both directions and it's capable of utilizing information from both sides. So that's what it's saying about BiLSTM, and that's the difference between LSTM and BiLSTM. So it goes into that. If you want to read about it, it's on the BiLSTM website. But I'm going to be making a blog post on it, and then when I make the blog post on it, then what I will do is I will go over LSTM and BiLSTM because that's what we're primarily concerned about in this particular code review. But I'm using some code that had GRU in it, so we're going to just go over GRU as well. So I created this program using Google Colab, which is a Jupyter notebook sponsored by Google. Google Colab is a great Jupyter notebook to use. The only thing that I would say is it doesn't have a very good undo function. And because it doesn't have a very good undo function, then you need to be careful not to accidentally overwrite or delete code. If you do that, you might be able to go into your changes, into save changes, and retrieve the code. But it's not always going to be the case. So, so what we'll do is we'll go ahead and go over the code. First thing we're going to do is we're going to import our libraries. We're going to import pandas, which creates your data frames and processes the data. We're going to create NumPy, which creates NumPy arrays, and it performs numerical computations. We're going to import sklearn, which what sklearn does is it provides machine learning functionality. We're going to import TensorFlow, which creates our neural networks. We're going to import matplotlib.pyplot_splt, which is going to visualize the data, and we're going to import Seaborn as SNS, which is going to statistically visualize the data. And we're using TensorFlow 2.12, and the reason why you need to know what version of TensorFlow you're working on is because TensorFlow goes through a lot of changes and a lot of their code becomes deprecated. So you need to know what version of TensorFlow you're on. We're going to set the random seed, so that means that the results will be the same every time you run the code. So tf.random.setSeed equals 42. We're going to read the file. The file that we're going to read is going to be from the rworld and data file, and the column index column is going to be number 3. That's your date, and then we're going to parse the dates. So that's going to be something we're going to do right away. So your date is your index, and then we've got all of these columns of data. We've got 66 columns of data. Obviously, we don't need all 66 columns of data because we're going to make this a univariate time series model. Check out the country. This tells you all the countries that are in the list, but what we're going to be, and you've got 255 countries or locations that it's going to be using. But what we're going to be looking at is the UK, and the reason why is because I live in the UK, so I have an interest in the UK, but you can look at any country that you want to look at because I'm giving you the code to figure out how to do it. So let's say hypothetically you're in Ireland, okay, and you want to know the COVID rates in Ireland, then you should be able to do that by coming over here, saying country, and it tells you all the countries or locations, and then rather than UK, you would just type in Ireland. So, and then after that, UK, what we're going to do is we're just going to make it a univariate time series data. So we're going to have UK new case equals UK COVID-19 new cases. And I also set up new deaths. I didn't actually do anything with the new deaths, but if you want to investigate the new deaths from COVID, then you certainly can do that. But one thing that I think is happening is the fact that I think they're not really doing COVID. They're not really tracking COVID cases any longer. But nevertheless, we're going to check for null values. It says there's 0 null values, but just in case that there were any null values, we're going to do a backfill. We're going to use pandas backfilled. UK new case dot fill in a method equals bfill in place equals true, and then you got 0 new case, 0 null values. We're going to visualize the data. UK new case dot plot dot show, so you can see that we visualize the data, and I think that they have stopped keeping records of COVID. So, but we still have a little bit. We still have a little bit that we can forecast. So now we're going to split our data into training and validating sets. And since I think they've stopped keeping records on COVID, what we're going to do is we're going to say the training size is 75% and the test size is 25%. And in theory, we could have made the training size 70% and the test size 30% if we wanted to. But we're going to split it up between train and test data. Now we're going to use sklearn's min-max scaler to scale the data, and the reason why is because I was researching and you're supposed to scale data on time series data because it just seems to work better if you scale it. But the thing about scaling the data is if you scale the data, you've got to go back and inverse scale it. So you've got to remember to do that. Now we're going to create the data set, and when we create this data set, it's just to make it. So create data set is X and look back equals 1. So your X is going to be your train scaled or your test scaled, and your look back equals 1 is going to be 1. So XS YS is 2 blank lists or 2 blank arrays. For I in range, len X, look minus look back, and look back is 1. V equals X, I to look back, I plus look back, XS dot append V, YS dot append X, I plus look back. And then return NP array XS, NP array YS, and then so X train Y train equals create data set X scaled 1, X test Y test equals create data set X scaled 1. So, and then we're going to check our shapes. So you've got your shapes of X train, Y train, X test, Y test. So you can see that. And now we're going to create the models. So we're going to create the GRU, which we're not going to really worry about that much because we're really concerned about LSTM and BiLSTM. But GRU, and then you create your LSTM. And so we're going to create a sequential model. Units is going to be 64. So model.add LSTM units equals units. Return sequence equals true. Input shape equals x.train shape 1, y.train shape 2. Then model.add LSTM units, that's your hidden layer. And model.add dense, that's your output layer. And then you're going to compile the model, and so you create the model and you've got 64 units. Now we're going to check BiLSTM because that's something that I had an interest in, so we created BiLSTM. So it's a sequential model, so model.add bidirectional, and so the bidirectional means that it can read the data coming and going. LSTM, units equals units, return sequences equals true, input shape x equals x train dot shape 1, x train dot shape 2, hidden layer equals model dot bidirectional LSTM, units equals units, model dot add dense, and then you compile it, and now we check. Now we're going to fit the model, and when you fit the model, that's when you train it. So we set it up for early stopping, and then so history equals model.fit, x train, y train, epochs equals 100, validation split equals 0.25, batch size equals 16, shuffle equals false, callbacks equals early stop. And then so you can see all this work that we've done, all of the training that we've done. Now we check the model performance. So you can see that on the GRU, the loss is very low. On the LSTM, the loss is very low. And on the BiLSTM, the loss is very low. So now what we're going to do is we're going to make predictions. And when you make predictions, you have to transform data back to its original state. So you're going to use sklearn's inverse method, or inverse function, scalar.inverse. And then you're going to make the prediction. We're going to be predicting on X test. But when we make our prediction, we have to inverse transform the prediction as well. Now we're going to plot it on a graph, which you will see. We're going to calculate the MAE and the RMSE, which you will see. So we've come over here, we check our GRU, RMSE is 6259, LSTM is 4260, and bidirectional LSTM is 5675. So you can see LSTM outperformed GRU and bidirectional LSTM in this particular instance. So you can see the predictions that the computer made, that the model made. So you can see that the predictions were slightly above the actual values. And you can see it looks like that in all three models. But see, now we're going to do some visualization as well. And so you can see that what we've done on the visualization on the GRU, the predictions are slightly higher than the actual values on GRU, LSTM, and BiLSTM. So that's very interesting, you know. So you can see that it worked out pretty good, even though the predictions were slightly higher than the actual values. You can see that the predictions pretty much followed it. And so that's it. That's it for our code review. I'm going to be doing another code review for you with something else. So that's going to be something for you to look forward to. And what I'd like to do is I'd like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. If you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And thank you so much for watching my video. I look forward to making more videos for you in the future.